In a computer code, something called a for loop means I'm going to do a set of instructions for a specified number of times. So let's see how this works on the Arduino. Okay, I'm going to start here with a absolutely blank sketch, and I'm going to work up to our code to show how a for loop works. So I'm going to put this in the setup part of the code, not in the loop part, because I want this just to run once. Now most of the time the code you write for an Arduino, you put it in the loop, you want it to loop over and over again. But there are times you would put a for loop in the setup, like to prepare a bunch of variables that are going to be used, like to fill up what we're going to call later as an array, for example. So to start our for loop, we type the word for, and then our left bracket, and then we have to define something we're going to call like the counter in the loop. I'll call this iCount. So there's three things go in here. So I'm going to start that, the starting value of my counter is going to be 1, semicolon, and then the next of the two things I have to say for what's the condition it tests when I know the loop is done. So as long as iCount is less than 10, we're going to keep looping. And then the last thing says, well, what do we do at the end of the loop? We're going to say iCount equals iCount plus 1. And then I put some curly brackets. So everything within these two curly brackets I want to be repeated 10 times. So let's put, for example, let's just say serial dot print line, and I'm going to put iCount. Now at the end of this I need my semicolon. It's kind of odd, at the end of the for loop you don't need the semicolon. Now because I've got a serial print, I'm going to have to say somewhere up here serial.begin and put the speed at which the serial port is running, 9600 baud. So let's check this code, see if I've done it right. Okay, I've missed something. So it says serial does not name a type. Okay, I think I want to put this down in my setup here. Let's try that. And let's check our code. Okay, now here's one. We talked about this in the lesson on variables. It says iCount was not declared in this scope. Now the scope where I put iCount is actually within the for loop. So I could either declare iCount as an integer variable within the for loop, within the setup, or up here at the top within the entire code. Now just to show you, let's define it just within the for loop. And to do that, I just typed the word integer here, so I'm defining that iCount is an integer. So on the fly, I'm defining its type, giving it a name and an initial value all at one time. So let's check that again and see if that code is going to work. Okay, this time it says expected declaration before the bracket. So it's pointing to this bracket here. Now let's check what's going on here. If I select a bracket, it said that one matches with this one, and this one here, okay, matches up here, but I've got an extra one here. So let me delete that. Notice what I'm doing. When I select a bracket, it shows me the matching one. So I managed to have too many of them here. So I'll delete that one and try this again. I'm trying to kind of illustrate, the debugging. You always have debugging and kind of looking at the logic of how do I find out what was the error. Okay, so that time it worked correctly. And let's open up my serial monitor, and then I'll send this code to the Arduino. And then notice very quickly it counted up to 9. Now I meant to count up to 10. So this is a very common error you can have in coding, is what they call an off by 1 error. So the problem here, I said when I count, as long as it's less than 10. So I really want to say it's less than or equal 10. So I want to include that last number 10. So let's check our code again here. So that's all good. And let's send it back to the Arduino, upload the Arduino, and then watch our monitor. And then this time, voila, it counts up to 10. So there's our loop that repeated 10 times, and we know it did because we put this serial print line statement. So this serial print line is really useful for debugging, to kind of see what's going on, to get the loop to work first. Now what if, say, I wanted to have it flash the light 10 times? So I needed to define my LED pin. Actually, what I'm defining is that's going to be an integer. Integer LED pin equals, and I think I've got it on, looks like number 9 here. So that's equal to a number 9 semicolon. And I have to define my pin mode on my LED pin. That's going to be an output. That would be all uppercase. Close my bracket with my semicolon. Okay, so down in here where I'm printing this, let's also put a statement here to say, let's say digital write to my LED pin. I'm going to set that to a high value. Now I'm going to have to also set it back down or it's not going to flash. Digital write to my LED pin to low. Now another thing I'm going to have to do is put a delay in here, though otherwise it'll be flashing on and off so fast I don't see it. So I'm going to put a delay of let's say 200 maybe 200 milliseconds or 0.2 seconds. And let's put this also up here. Now to clean this up, let me just space these over the same as the brackets. Makes it a little easier to see the brackets and what's inside the bracket. So does that look right? And I never know if it is or not, so I'll check my code first. Okay, that time I got it right. So let's upload this and turn on my serial monitor. And now notice it's flashing, and as it flashes it's counting also here, so it's sending the number to the serial monitor while it flashes. Let's clear this out. This time if I just push this reset button and start it over and watch that again. So as the light flashes, it puts the number of the loop counter out out there in the serial monitor. Alright, so there's an example of how we use a for loop to do something a certain number of times. Let me show you another example. Let me open up one I created earlier. This one is gonna, what this program does, I have a for loop, and I use counter as my count, and I'm counting for rows is the number of rows, and I'm going to build a table here of degrees F and degrees C. And so this time I use floating variables because this is a decimal number. So I'll start at -40, and I'll define temp C. I don't know what it is yet, so I'll just define it as a floating variable. And I'm going to say I want to have 127 rows, and then I'm going to increment my temperature by 2 degrees. So down here in my for loop, I count 1, and I add 1 to the count every time, and I'm going to count up until my count equals rows defined up here. And what I'm going to print then is here's the equation for temperature degrees C equals temperature degrees F minus 32. So at 32 degrees F, we're at the freezing point of water, which is 0 degrees C. So I subtract 32 and put that in brackets, and I'm going to multiply by 5, divide by 9. So that gives me temperature degrees C. And so then I'll print out temp F, and then to put a space between them, I could have just put quote space, but \T puts actually a tab character. We'll line it up nice and neat in the format, and then I print temp C, and then I say, okay, temp F equals temp F plus the temperature increment. Let's see, one other thing I think I want to put, oh, here it is. At the top of, before the loop, I put a header. I'm going to print temperature, and then on another line, degree F and degrees C. And then I'm going to loop 127 times and print a table of temperature F and temperature C. So let's upload this and open up our serial monitor. Okay, and here's my table of values. Now I don't know, I often get these funny two little characters when the thing gets started. Something about in the serial transmission, there's some goofus characters get in there at the beginning, so we'll just ignore that for now. So a couple things to note. Notice that at -40 degrees F, this is the one point in the temperature scale where the two temperatures read the same number. And then notice at 32 degrees F, we're at 0 degrees C. That's the melting point, or the freezing point of water. And then we get up to 212, that's the boiling point of water. That's 212 degrees F, or 100 degrees C. So here's a little table of values. If I want, I could select this whole thing. And then I can type Control-C to copy that. And then let me bring up a new blank Word document. So I could then paste that in here. Whoops. And because I have a tab character, I can select it all, and then I could put a tab and move this over to format that more nicely. So here's my table of, now I could also let's put the rows closer together. So here's my table of degrees F, degrees C. And I did that with a for loop to calculate those values. So that might not be the normal thing you'd use in Arduino for. I just want to demonstrate how a for loop works. Now, one other thing I'd like to show you, I think it'll be surprising to you how fast this Arduino can actually run. Now, it's certainly not the fastest computer on the market now, but for what it is, for little experiments, I think you'll be impressed at how fast this is. So let me open up another example I created before. I called it for loop timing here. So what I'm going to do here, so in this one I have a for loop that's going to repeat 10,000 times, and in here just to have it doing something, I'm going to put a couple things. I'm going to put, let's say, last count equals count. So when we get done with a loop, we can assure ourselves, okay, that was the value, was the last time through the loop was the value. And I'm going to have it just do x equals square root of, turn the count into a floating number and find the square root. So the square root of 1 is 1, the square root of 2 is something like 1.14, the square root of, well anyway, square root of 4 is 2. So it has to do a calculation just to slow this thing down a little bit. But I don't have any delays in here. But after the loop is done, let's actually, at the start, before the loop, I'm going to print start. So we'll know where we are. We're starting the loop. And then I'm going to capture what the time was. So there's a function in Arduino called millis or milliseconds. So I'm going to say time 1 equals the milliseconds that occurred. I do the loop, and then I'm going to say time 2 is the milliseconds after the loop. So the loop time to do the 10,000 calculations is time 2 minus time 1 divided by 1,000, because that's milliseconds, so I'm going to convert it to seconds. So then I'll print, and we're done with the loop, the count, and I'll print the last count so we know it did it 10,000 times, and then I'll print time in seconds equals, and then print the time it took. Okay, so let's double check that this code works. It compiles properly. And I'll send it to the Arduino, open up my serial monitor. Now, here it started, it ended, it did it 10,000 times. It did it so fast that it did it within a millisecond. So it's tenths, hundredths, thousands. So it was within far less than what I printed out here. So it was just a few milliseconds at the most. So let's change this to something bigger. Now, a problem with an integer, I wanted to show this example. An integer can only go up to 32,000 something, or it runs out of bits and starts over. So the highest I can go is like 32. Let's see, where am I here? Let me say 32,000. And let's run that again. So again, the time still doesn't even show up tenths, hundredths, so it's a fraction of a thousandth of a second. It doesn't even show up. So to make the loop a larger number, I have to change the counter to be a floating number. So I'll change that to a float. Now I'll show you, just making it a float will make this take a little bit longer. The integers calculate faster. So let's change nothing but the float here and send that to my Arduino. Okay, so that time it took 0.41 seconds. So just converting the counter to a floating number, so it has to add a floating number to a floating number, took a little longer. but it still did 32,000 calculations in 0.41 second. So what if, let's change this to 100,000. Whoops. There we go. That's 10,000. Now there's 100,000. Okay, let's try this 100,000 times. Now most of this time is taking just compiling the code and sending it to the Arduino. So it started, it ended, and so that took it 1.25 seconds to go 100,000 times and to do several floating point calculations each time. So you can see how this thing is quite fast. That's why if we want to watch what happens, we have to put delays in to slow it down. It's pretty extremely fast. Well, I got to run. My phone's ringing, so I'll see you in the next video. Bye.